This is 5 minutes. What is the answer? You put that back. Okay. You're going to go and buy. Down, bring that mic back.
Esther, you dey party ni? Esther, mute your mic now.
Everyone is welcome to this class. I want us to finish everything that has to do with alkane today. I want to know that you're hearing me. If you can hear me, I want you to unmute and respond. Good evening, everyone.
Good evening, good evening.
Okay, so we're not waiting for anybody today. So let's continue. We've talked about alkane. We talked about the... Please, Ido, you are the co-host, so please control the class. We'll talk about the physical properties. We'll talk about classes of alkene halide. Talk about the primary, secondary, and tertiary alkene halide. Talk about the lower ones are liquid, and the lower ones are gases. The medium ones are liquid, higher ones are solids. I will talk about their solubility, that branch chain has higher melting point and boiling point than branch chain has lower melting and boiling point than straight chain, because they are the molecules are crowded together. Within themselves, they generate heat. So that's why branching has lower melting point and boiling point. And we talk about the sources of this natural gas, petroleum and coal. I said you have to know these sources. And we'll talk about that those things are obtained from petroleum using fractional distillation, where we heat, and these fractions are going to come when the heat gets to their boiling point. So that's what we call them fractional distillation. So that's a method used in a refinery in obtaining or separating crude to get the fuel you use. So today's we are going to talk about this. How do we synthesize this alkane in the lab and industry? Now, normally industries are a place where we do small production. Industry is a place where we optimize our game. In the lab is a place where we do in small quantity. Now, in terms of purity, laboratory are more pure because the lab reagents are very pure. So in industry, that's why mass production. So at times they go ahead to purify. Because in the industry, they're looking for how to optimize profit. But lab are looking for how to get the real products. So they're trying to see how can this thing be feasible. So they're looking at the feasibility of the reaction. But after knowing the feasibility of the reaction in the lab, I'll go to the industry to optimize profits. Whenever you're preparing in industry, there's always mixture of products. And at the end, they're going to do separation to get the one they're looking for. But in the lab, we're always getting pure compounds. Industry, they have dedicated apparatus for whatever they want to do. Unlike in the lab, we have flexible apparatus. That's why you can use one for another. But in the lab, in the industry, each apparatus is dedicated for whatever they want to use it to do. There's no flexibility. This one is for synthesis of alkene. They have a place for that alkene. They have a place for another thing. So they dedicate apparatus for each synthesis they want to do. 5 seconds. So now we are going to talk about how do we synthesize this alkane in the lab. Number one method is reduction of alkyl halide. I want to remind us what is reduction. Reduction is reversible reaction of oxidation. Oxidation from secondary school is addition of oxygen. Addition of oxygen or removal of hydrogen is called oxidation. That is what happens when you cut your apple and apple changes color. Because apple have obtained oxygen from the air and is oxidized. And that is why it's advisable, don't cut your apple and keep. If your children are going to school, don't slice apple and put inside the flax or something for them to go to school. But at the end, they are not getting the nutrients from that apple because apple has been oxidized. Anything that is oxidized is not healthy. Now, oxidation is addition of oxygen or removal of hydrogen. While reduction is reversible. Reduction is removal of oxygen or addition of hydrogen. So whenever you see a reaction and they say this reaction is undergoing oxidation, you have to check either in that reaction, oxygen is being added or hydrogen is being removed. So, and if you see a reaction is undergoing reduction, look at that reaction. Either hydrogen is being added or oxygen is being removed. Now, in reduction of alkyl halide, one, either we are doing hydrolysis of greener reagents. In hydrolysis of greener reagents, we are going to add water in greener reagents, and that water will separate into hydrogen and hydroxyl. So hydrogen from this water will be added to whatever we have to get the alkane we are looking for. We can also do this reduction using active metal in an acid. Active metal can be, okay, let's go to let me not be talking something that is in the air. Now, this is hydrolysis of greener reagents. When I have, remember, it's from alkyl halide. When I have my alkyl halide can form greener reagent by reacting with magnesium. The formula for greener reagent is RMGS. The R is alkyl. It can be methyl, it can be ethyl, it can be propyl. R can be any alkyl. Then X is halogen. It can be any halogen. But what is often used is bromine. But any halogen can be used. But bromine is often used. Now, when I get this my greener reagents, in the presence of hydrolysis means addition of water. It's opposite of dehydration. Now, hydrolysis can be also called hydration. When you lose water by virtue of diarrhea, they say you are dehydrated. So what you need is to hydrolyze or hydrate, addition of water. So in this addition of water as a molecule can split into ions. The ions are hydrogen and hydroxyl. So when we are hydrolyzing our greener reagents, the hydrogen aspect is going to go and replace the MgS, forming the alkane. Remember, we are forming our alkane. Now, how does it go? This alkyl, this RMGS is going to split into two. Splitting into two, remember, magnesium is highly electropositive. So magnesium is going to get the positive section, while alkyl is going to get the negative one. So in breaking, the bond is going to break towards alkyl, giving it negative charge. Now, remember, when my water is going to ionize, it's going to form hydrogen ion and hydroxyl ion. And in chemistry, unlike is going to attract. So that hydrogen ion, which is positive, is going to go and migrate and bond with alkane, which is negative, to form alkane. Why the magnesium, which is positive, is going to be attracted by hydroxy group to form the byproduct. In any reaction of synthesis, byproduct is not always our concern. The target molecule, which is in this case alkane, is what concerns us. So the side product. So in the exam hall, even if you're told to do this as a question, and you end up giving us just the alkane without adding the side product, you will not be penalized. But adding the side product show us that you know what you're doing. Now, this is a general scheme. So in the exam hall, you cannot use R and you cannot use X. You tell us the specific R. So assuming you're meant to synthesize propane, it means that my R will be propyl. So it will be N-propyl bromide or bromopropane. In the midst of magnesium, I'm going to form a greener reagent called propyl magnesium bromide. In the presence of hydrolysis, like we said, the hydrogen is going to replace MgBr, forming a propane. Then the other one is side products. In the side product, will simply because magnesium is electropositive, so that's what is going to attract the hydroxy group. So that's why magnesium is in hydroxy group is in the bracket, telling us that the magnesium has two bonding sites. One is for hydroxy group, the other one is for bromine. So this is method hydrolysis of alkyl halide. Remember, the method of synthesizing alkane is via reduction of alkyl halide. In that reduction, either I do hydrolysis of greener reagent or I react with active metal. In reacting with active metal, what we simply do is metal in HCl. The hydrogen we are looking for, please, course rep. The hydrogen we are looking for is coming from the acid. So acid is going to release the hydrogen ion that is going to replace where chlorine left to form our alkane. So that's what happened here. Now, if I don't want to use tin, I can also use zinc. Now, that zinc and hydrogen ion can also be called zinc and HCl, because it's from HCl that we're going to release the hydrogen ion. Okay. What are the reactions of alkane? In preparation, we just do reduction, because remember, alkane, to form alkyl halide, one hydrogen was lost. Now, removal of that hydrogen or addition of oxygen, we call it oxidation. So now when I want to form the alkane back, the hydrogen that was lost is what I was adding by reduction. So in that reduction, either I do hydrolysis of alkyl halide, hydrolysis of greener reagent, or I use active metal to generate my hydrogen that will replace that which was removed when alkane becomes alkyl halide. Now, because alkane are saturated compounds, they don't always undergo much reaction. Just like saturation is that you have enough. It's only an angry man that is a hungry man. If you're filled up, things will not make you angry. But when you don't have money in your account and and you have a bill to pay, every small thing you react. Your reaction is not what happens. Your reaction is because you're unsaturated. So in terms of reaction, when a compound is unsaturated, they react faster. When a compound is saturated, reaction is very slow. So that is why, because alkane are saturated, it cannot undergo so much reaction. Now look at, with sulfuric acid, it cannot undergo, it cannot react. With base, which is, so with an acid, no reaction. With base, no reaction. With sodium metal, no reaction. With permanganate, potassium permanganate is a sign of oxidation. It cannot react. Hydrogen and nickel is talking about hydrogenation, no reaction. With bromine water, it cannot react. With water, so it virtually cannot react with anything. Alkane are typically non-reactive. They don't react with acid, base, active metal, oxidizing agent, reducing agent, halogen. Then what happens to alkane? Alkane can only undergo reaction called halogenation, combustion, and pyrolysis. Remember, they have saturated bond. So when they want to react, they are going to do swap. So there will be exchange of hydrogen with any of the reagent that you want to happen. So that is why reactions of alkane is called substitution reaction. You're swapping, substituting. So you're replacing one atom with hydrogen. So that's what happened in halogenation. In combustion, which is an oxidative reaction, alkane is going to interact with oxygen from air and they are going to burn. In pyrolysis, we are talking about cracking. When higher alkane is breaking down into smaller alkanes. So let's look at the reactions one after the other. This is halogenation. In halogenation, this hydrogen that is flying is going to be replaced with chlorine. Halogenation reaction is a method of forming alkyl halide. So halogenation is a substitution reaction. This halogenation occurs in the presence of heat or light. So either UV light or use heat for the reaction to occur. And we need halogen for this reaction to occur. And at the end, we can form mixture of products. And this hydrogen, primary, tertiary, secondary, primary, and methane. Meaning that in terms of reactivity, tertiary is more reactive. And methane, that is after primary, we have methane. Remember, primary is that the carbon must have at least 2 hydrogen. But in methane, you can see that the carbon is having 4 hydrogen. So we don't term it to be primary. Remember, I said in terms of reactivity of halogens, bromine is more reactive. Bromine is more selective. Sorry, bromine is more selective. Now, meaning that whenever I'm doing halogenation reaction, I cannot use fluorine because fluorine is very corrosive. So that's why if you look at chemistry textbooks, you can see that fluorine is rarely used, except a reaction, except that fluorine is like a part of the reactant. It's very, very corrosive. It's very, very highly reactive that it can cause explosion. So that's why we always use chlorine. Then, in terms of reaction, we always use chlorine. Chlorine is more reactive than bromine. But when we are forming a greener reagent, because bromine is not very reactive, we tend to use bromine for greener reagents. So in this particular halogenation reaction, chlorine is more feasible because bromine is more selective. Iodine is not used. So we use many chlorine. So we call them chlorination reaction. Combustion. Remember I say combustion is when there's interaction with oxygen, which can cause flame. Whenever there is oxygen, that's what happens when you burn. That is what happens when you're cooking. That's when you're using charcoal to cook. When there is no oxygen, there is no air, that charcoal cannot produce flame. So when alkane reacts with oxygen in the presence of heat, it's going to produce carbon monoxide and water, and then heat will be generated. That is CO2. Then this is a reaction that occurs naturally in the atmosphere. So whenever there's interaction of this alkane with oxygen, they're going to form CO2. And remember, this CO2 is what the plant will take and release oxygen for us. Pyrolysis, or also called cracking, is when high molecular alkane under high temperature is reduced to low molecular alkane and hydrogen. So we call it cracking. The way you crack things, whenever you're cracking things, you're breaking them down into lower forms. So that's what happened in cracking. So the reactions of alkane are three reactions. Number one is halogenation. Number two is combustion. And number two is cracking or pyrolysis. So you should be able to understand and know these reactions of alkane. And remember, in terms of halogenation, alkane halogenates via substitution reaction. So when we go further, we're going to tell you what is the nature of this substitution reaction. So this is substitution reaction, where our normal butane can form chlorobutane. It can also form either primary or secondary. But in terms of, whenever you see percentage, you're telling you which one has more feasibility or stability. So we are talking about secondary is more stable and tertiary is most stable. So in this kind of reaction, what is much more feasible is secondary chlorobutane or butyl chloride. Now, when isobutane reacts, we are going to form isobutyl chloride and tertiary butyl. In that case, the most stable one here is isobutyl. Why? If you look at it, you know it has methyl already. So it's more stable because it's like in secondary form. Because that methyl we are seeing, this is called secondary alkyl halide. This is primary alkyl halide, but the methyl there is having secondary function. So that's why the percentage is higher, 64%. So whenever I'm using isobutane, the one that has more stability is the one that is isolable. So in this case, we are having 64% for isobutyl. While tertiary, that we expected to be more, is having less visibility, being 36%. So some of these percentages is what is being determined in the lab. It's telling you that when I did this reaction of isobutane when I chlorinated it under UV light, the one that gave me the higher yield is the isobutyl chloride. The tertiary butyl chloride did not give me as much yield as that. So it's not something you need to cram. It's determined experimentally. Now, ethane under bromination is going to give us bromoethane. See, these are just reactions of alkane under halogenation. In halogenation, what you simply do is to swap one hydrogen with halogen. And then the remaining, that hydrogen that was swapped is going to form bonding with remaining halogen to form hydrogen halide. It can be hydrogen bromide, hydrogen chloride, any of them. But remember, whenever you're just forming your reactions with alkane, halogenating alkane, you're removing one hydrogen and replacing with halogen. That's what we call substitution reaction. So these are the reactions. All these ones you're seeing percentage should not bother you. We're talking about how much yield that was able to obtain in the lab. So which means the one that is much more isolable, that is feasible, that is something you can hold hands and say, there's something here, is secondary. But in this ISO, you realize that whenever you use normal alkane, you're going to form secondary to be much more stable. And whenever you use isobutane, you're going to find tertiary to be more stable. Now, we also have cycloalkanes. Cycloalkanes are alkanes that is in a ring form. Meaning that in the normal alkane, the tertiary carbon, the terminal carbon will always have 3 hydrogen. But in this cycloalkane, all the carbons have 2 hydrogen because they are all in a ring. So alkane that contain a ring of carbon atoms are called cycloalkanes. And in that ring, the minimum that can form ring is 3 carbons. So that's why the list of cycloalkanes is cyclopropane when carbon is 3. When carbon is 2, they cannot form a ring. It's only 3 that can form a ring. So remember, in terms of isomerism, 3 cannot form isomer. Isomerism starts at carbon number 4. Please don't forget. Now, I can also use a polygon to represent my cycloalkane. When I use 3 sides, I will call it cyclopropane. When it is 4, I'll call it cyclobutane. So the number of the sides will determine the cycloalkane formed. If the side is 6, I'll call it cyclohexane. Hex is talking about 6. Cyclo means is in a ring. Ane means is alkane because I can also have cyclohexene. So double bond can also form a cyclo compound. It must not be only saturated compound. Remember, still being in ring form, they are saturated compounds. So ask your question on this. So let's know whether we can treat another topic.
I
Or
do
we
those
go for
sizes, ma. Go back to the last slide, ma. Those cyclopropane, cyclobutane. How do you determine the 1, 2, 3, 4, 5? 1, 2,
is the
3,
number
4.
of the side.
Okay. Okay, ma.
The number. So what you need to put cyclo because in a ring and ane because it's alkane. Is that clear? Ask your questions on this. So in summary of alkane, is alkane are saturated compounds. Being saturated, it means that they don't have any double bond or triple bond. They have single bond. And because they are saturated, when the higher members, the higher the molecular weight, which means the more the number of carbons, the lower the solubility. Normally, remember, C1 to C4 is gases. C5 to C6 are liquid. Above C6 are solid. So higher ones are solid. Well done. So what am I saying? So now, in summary, the higher the molecular weight, the more they become solid. So that's why they move from gas to liquid, from liquid to solid. And we talk about that the straight chain has higher melting point and boiling point more than the branching. Because when they are branched, they are crowded. So within themselves, they generate heat. So when there's any small heat, they boil, or when they are liquid, or they melt when they are solid. Then we talked about that these alkane are obtained from fossil fuel, coal, and petroleum. And we also say that they can be separated from petroleum by fractional distillation. Fractional distillation is that whenever you're heating, each fraction comes when their boiling point approaches. And we also say that this alkane can be synthesized in the lab and in industry. Industry is upgrading, scaling up. In the lab is more pure because all the lab materials are pure. Then the essence of industry is to optimize profits. Then we also said that they can be synthesized in the lab using reduction of alkyl halide. And I said that reduction simply means addition of hydrogen or removal of oxygen. So in this kind of reduction, what we are doing is we are adding hydrogen. The reduction can either be hydrolysis of binary reagents or addition of active metal via an acid. So in all this is what we are doing, we are removing the halide and replacing with hydrogen. Remember from the one, alkane is formed by alkyl halide is formed from alkane by removing hydrogen and replacing with halogen. So we are doing reverse by removing the halogen and adding back the hydrogen. So that's what we're doing by reduction of alkyl halide. So we talk about in reactivity, these alkanes are not reactive. They can't react with acid, they cannot react with base, they cannot react with salt, they cannot be oxidized, they cannot react with water, they cannot even react with halogens in addition. So the only reaction they can undergo is substitution reaction. In this substitution reaction, they undergo halogenation. And the halogen that can be used here is mainly chlorine. In that case, we are going to form our alkyl halide. So we are always, whenever you're talking about reactions of alkane, you're moving from alkyl halide back to alkane, or from alkane to alkyl halide. That's a reaction. Then we talked about pyrolysis or cracking. We say in that pyrolysis, you move from lower, you move from higher molecular alkane to lower ones. So they crack, they reduce, they move from higher ones, lower ones, alkane and hydrogen. That's product of cracking. And we also talk about the last one is combustion. When alkane burn in air in the presence of flame, they are going to form CO2 and water. The CO2 is that's what happens when you heat wood. Those flames that come out as CO2. That's why they are poisonous to human being. But the trees need it for survival. When they take this CO2, they release to us oxygen that we need. Then, after which we came and said that, beside that this alkane can also form a ring, which we call cycloalkane. This cycloalkane is determined by the number of sides. If they have 3 carbons, we call them cyclopropane. And we say the least for the ring to form is 3. So the least for cycloalkane is 3 carbons, which is cyclopropane. Then we have others. I would say instead of writing carbon and hydrogen, it can be represented with polygons. So number 3 means cyclopropane, number 4 means cyclobutane, and others, as shown on the slide. So that is all about alkane. If there's no other question, I want to give you assignments. So I think if you can be making this class, just like now, we can actually optimize our time here because the network is not fluctuating from my end. Whenever I'm in office, network fluctuate because that place naturally don't have good reception. So that's why I prefer having this class in a time like this. In the next class, we're going to dive into alkene. But I'm going to share the slide of alkene now. So you can have a foresight. You can peruse through the slide. I would have loved you to go through the slide, even if it's not making sense. So when I'll come to class, I'll be talking about it. Those things that does not make sense will make more sense to you. And those ones that make sense, I will help you revise them. So that's the so your assignment, please, can you write? Question 1. Write the isomers of pentane. Write the isomers of pentane. Write the isomers of pentane. Remember isomerism. So my pentane is supposed to have straight chain. So supposed to have many branches. Branch 1, branch 2. So write the isomers of all the isomers of. I think this thing, the only thing I did, I was not recording, but it's on YouTube, so you can go and watch it on YouTube. You can also go there and download it and keep it in your phone and watch. So, isomers of pentane. That's number 1 question. Number 2 question. Using bromohexane. Classify bromohexane into primary, secondary, and tertiary alkyl halides. Classify bromohexane into primary, secondary, and tertiary alkyl halides. I hope you are getting the question. That's question 3. What are the sources of?
Yes, ma. I did not get question 2, please.
Classify bromohexane into primary, secondary, and tertiary alkyl halide. Bring that something. To bring us something. Want to drink away. Take money, go and buy it from that one. No. From the man. How much is that? Take 3,500.
Yes, ma. We can't hear you anymore.
Is it 3,500 or 3,000? 3,000 pence. 3,000. Now I said classify bromohexane into primary, secondary, and tertiary alkyl halides. Now, let me give you clue on that question. Remember, when we are talking about, let me go back to the slide where we are talking about classes of alkyl halides. So you understand what I'm expecting from you. Now, this is what I'm expecting from you. 1, 2, 3, 4, 5. This is pence. This is pence. In this pence, we have primary, we have secondary, we have tertiary. Remember, primary, the carbon that bears the halogen is going to have 2 hydrogen. Secondary, the carbon that bears the halogen is going to have 1 hydrogen. Tertiary, the carbon that bears the halogen will not have any hydrogen. So we're going to use bromohexane to show primary bromohexane, secondary bromohexane, tertiary bromohexane. At times, because it's hex, you might have more than one secondary. You also have more than one primary. So remember, talking about isomerism, you know we are going to have branching and straight chain. So do what you can do. I'm going to do the correction, especially of this one in the class, next class. And make sure you submit before the next class so I can do the correction. Then, what are the sources of what are the sources of fossil fuels? What are the sources of fossil fuels? We know the three major sources. How is alkane obtained from petroleum? How is alkane obtained from petroleum? What is the principle of fractional distillation? When you hear the word fractional distillation, what comes to your mind? What's the principle of fractional distillation? If you can now, the essence, if you can be able to answer all these questions in this classwork, it means that every question that comes out in alkane, you can answer it. Mention the two methods of preparation of alkane. Mention the methods of preparation of alkane. But trace your answer with equation. The equations are simple equations. So select one of the equations. Remember, each of the equations have more than one. So anyone that is okay by you is fine. Now, in terms of hydrolysis of Grignard reagent, you can start from Grignard reagent and just add water. You must not form the Grignard reagent. The essence of this slide is for you to understand how this Grignard reagent is formed. But remember, the method said hydrolysis of Grignard reagent. So you can go ahead, use already formed Grignard reagent, hydrolyze it to form your alkane. But don't use R, you have to use your named alkane. You're given an open check in this question. So even if you want your own alkane to be just ethyl. So if you want your Grignard reagent to be N-ethyl magnesium bromide, it's fine. So when you come here, either you use your tin in HCl or use your zinc in HCl. Any of them is fine. But remember, you will not be penalized for not writing the byproduct. The most important thing is the target compound. Then, what are the reactions of alkane? Mention the reactions of alkane. You may not be expected to tell us all the reactions, but you should be able to mention the reactions of alkane and give us equation for at least one. And give equation for at least one. So you're expected to give at least one equation. So in this question, you're going to mention the three reactions of alkane. Then anyone that is easier for you that you can remember, give us the equation. So that is all for your classwork. Question.
Hello, ma.
Yes.
I would like to go over the questions to know if I'm on the same page.
Okay, go ahead.
The first question is said that we should write the source of pentane.
The isomers of
Isomers of pentane. Second one, he
So
said we should classify Brumo Eze into primary, secondary, and tertiary
and
Akia line.
tertiary. Yes.
And number three, he said we are to find the sources of fossil fuels
Yes.
and how is Ake obtained from petroleum.
Yes.
The next one is we have to find the principles of fractional distillations.
Yes.
Then mention the method of preparation of Ake with equations.
Okay. Yes.
And the last one is what are the reaction of Ake and equation of one.
Yes.
Okay, thank you.
So who is still raising hand? Ayola, are you done still raising hand?
Ayole, let me put it down now.
Ayole. Okay. So any other question from the house? Be free to
Me
ask your
this thing
question.
now. Eh,
Be free to ask your question. Ayole, Ayole, make sure you share the question so I can upload it on your on your Google Classroom.
Okay, ma,
So
fine.
share it on the group page. So there's no other question, right? So I think I want us to use the remaining 1 hour for this course to do this classwork and submit. When can we have this class again? Can we have it tomorrow? By this time tomorrow? Is it possible?
Tomorrow is Wednesday. We're having Dr. Mary tomorrow. We can have it on Thursday.
Ayole.
As I'm talking, I said tomorrow is Wednesday. We're having Dr. Mary on Wednesday. So we have it tomorrow. We have you on Thursday.
Okay, so let me know the time. Just so
Okay,
I can prepare the Zoom class. But like you can see
okay.
now, even if I have more things to say, I have enough time to say it. So network is calmer here. So that's why I prefer this time. So we can flow and achieve more. But this class, we are dealing with the basis. So if you want to know more about organic chemistry, you can watch on my YouTube. For this class, we're going to end in the basis. So after alkane, we are going to do alkyne. I think and one other, maybe benzene, and then we are done. So if you have like a good 2 hours every week, in the next 3 weeks we should be done. Then, but what I would have wanted us to do is that be writing down your questions because I'm going to come out on one class to answer your questions. Then at that moment, I'll be free and said, my conscience is clear for your exams. So if there's
Sorry,
any
ma, I want to
question,
ask you a question, ma.
okay.
The question given is supposed to be classwork or assignment, ma.
Both classwork and assignment is the same thing. Class,
Okay.
because why I said this is that because we're supposed to end this class by 7. And because what we have to do is small. I don't want to start a new class on this. I want you guys to digest and assimilate this before we go to our king. So the remaining 1 hour, I will employ you to optimize it to answer this, to do this classwork as it's hot now, as it's still fresh in your brain. So that before the next class, if there are things you did you're not sure of, I can review the assignments. So everybody will be on the same page.
Okay, ma, thank you.
Yeah. So any other question? So when do you think it's okay for your submission?
Can we do on Monday now?
If it's on Monday, it means we are not having class again this week. So we're
We
not
can have
having
on
class again.
Thursday. We can submit on Thursday. We have a class on Friday.
Okay, because I want us to submit before the next class. So
Okay, we
it
can do
depends
it
on
on
your
Thursday.
whenever you're ready, inform me a day before so I can
Okay,
align my schedule. All right. Okay.
Yes, ma'am.
Enjoy your evening.
Thank you, ma'am.
Bye for now.
Thank you, ma'am.
Thank you, everyone. And bye.
Thank you, ma.
Thank you.